Hello students, in the previous lectures we have seen the kinematic degree of indeterminacy for beams, pin jointed structures and rigid jointed structures. Now it is the last lecture from this chapter and it is for kinematic indeterminacy of hybrid structures. Now we know that hybrid structures are the structures in which along with the rigid joints some joints are other types of joints. Now we also know that the kinematic indeterminacy is nothing but the total degrees of freedom for the given structure. So as such, in order to get the kinematic indeterminacy, we should know the degrees of freedom for these different types of joints. Now the different types of joints which can happen are shown over here, and I am going to discuss the degrees of freedom for these joints also. So the first row I have shown over there is for joint. So there can be this hinge joint in which two members are connected by means of this hinge. Then it is a vertical shear joint, release joint, and all other joints are shown over there. And let us see what are the degrees of freedom. Now in this case, that is the first case in which two members are connected together by means of this internal hinge. Such joint has 4 degrees of freedom. The deformations, displacements that can happen are delta x, means movement along x direction, delta y, that is translation along y direction, theta 1, that is rotation of member number 1 and rotation of member number 2 are going to be different for this type of joint. So these are the 4 displacement components, and that is why degrees of freedom for this joint is 4. It is the second joint. Now here the two members are connected by means of such joint in which rollers are placed in between. Now the degrees of freedom can be like this: delta x, that is the movement along x direction is possible. So it is the horizontal movement or horizontal displacement delta x. Then the vertical displacement for left member and vertical displacement for right member is going to be different, or it may be different, delta y1 and delta y2. So two vertical displacements, one horizontal displacement, and third one is the rotation. Rotation is going to remain common for both of these members. So theta, that is rotation, is common. So 4 such displacement components are there. Degrees of freedom is 4. Now here in this case of joint, delta x, that is horizontal displacement, delta y, the vertical displacement, and as 3 members are connected together by means of an internal hinge, so theta 1, theta 2, theta 3, the rotations of all these members are going to be different. So 5 degrees of freedom for such joint. 4 degrees of freedom for this type of joint: delta x1, that is horizontal displacement of member number 1, horizontal displacement of member number 2 is delta x2, delta y is the vertical displacement, and theta is the rotation, which is going to remain same or common for this type of joint. Now it is a rigid joint, we know, and in case of rigid joint, delta x, delta y and theta, that is rotation, which is common for all the members. So 3 degrees of freedom for a rigid joint. And in this joint I have shown this vertical member, and to this vertical member, this member, another member is connected to the first member by means of a hinge. So hinge is for this member only. So here also 4 degrees of freedom, delta x, delta y, theta 1 and theta 2 are going to be different for this vertical member, and theta 3 is the rotation for this member which is connected to the first one by means of an internal hinge. So these are the degrees of freedom which are there for typical types of joints. Now hybrid structures are classified into plane and space structures. In case of plane structures, dk is given as 3j minus r plus m plus rr, where m is equal to, this m is equal to axially rigid members, where rr is equal to summation of m dash minus 1, m dash is equal to number of members meeting at hybrid joint. Now because of these joints, see, you can check that this is the rigid joint. So in case of rigid joint, the degree of freedom is 3. But for rest of all joints, the degrees of freedom is either 4 or more than that. So instead of rigid joint, if some other type of joint is used, the kinematic degree of indeterminacy will be increased. It is definite. You can see it from here, and that is why we will have to add RR over there. RR is the increase in degree of freedom, increase in degree of kinematic indeterminacy due to introduction or due to use of some other types of joints instead of rigid joints. And this is how the formula for plane frame can be used. Formula for space frame is 6j minus r plus m plus rr. It is similar to that one. Now, in order to explain it correctly, I am considering a frame in which some joints are rigid and some are, now I have considered these two joints as hinge joints, and let us see the degree of kinematic indeterminacy in this case. So dk is given as 3j minus r plus m plus rr. 3 times j, number of joints is 9 over here. So 3 times 9 minus r plus m. R is the number of unknown reaction components. So here these are the reaction, or these are the vertical component, horizontal component, and the fixed end moment. So 3 over here, 3 over here, it is a hinge support. So 2 over here, number of reaction components is 8, and plus number of members is 1 2 3 4 5 6 7 8 9 10. So 10 is the number of members over here. 8 plus 10 it will be, plus summation of m dash minus 1. M dash is the number of members meeting at hybrid joint. It is one of the hybrid joint. It is the second hybrid joint, and as there are two such hybrid joints and which are similar, I am using 2 for that, and m dash minus 1. M dash is the number of members meeting at those hybrid joints. So at both of these hybrid joints, number of members meeting is 3. 3 minus 1 into 2. So this total becomes dk is equal to 30. So degree of kinematic indeterminacy for this given frame is 30. Now here we are considering that all the members are rigid, all the members are inextensible. If it is mentioned that some of the members are extensible, then we will have to think about this term m. So m, if extensibility is given, then we will have to consider, or if all the members are given as extensible, we will have to consider m as 0, and in that case the degree of kinematic indeterminacy will be more if the members are extensible. But it is common practice to assume that the members are rigid. So dk is equal to 13. You can calculate the degree of kinematic indeterminacy just by counting the number of degrees of freedom also, and which can be done like this. Now there are these rigid joints 1, 2, 3 and 4. Now every rigid joint has a degree of freedom is equal to 3. So 3 over here, 3, 3 and 3. So 4 joints are having degrees of freedom is equal to 3. Whereas there are these two hybrid joints in which internal hinge is used, 3 members are meeting. So for such member the degree of freedom is 5. So 5 over here, 5 over here, and degree of freedom over here is 1 because it is a hinge support. So if I add them together, I can get dk is equal to 23 plus 3 plus 3, 12 plus 10 is 22, and plus 1 is 13, minus the number of members. Number of members, that is equal to 10, and dk is equal to 13. Now just by counting all the degrees of freedom, we are considering the axial displacements also, but these axial displacement should be reduced to 0 if the members are inextensible, and that is why I am deducting 10 from this. 23 minus 10, 10 is the number of rigid members, so 10 I am using over there, and dk is equal to 13. So this is how you can get the degree of kinematic indeterminacy just by counting the total degrees of freedom. So 23 gives us, or this number gives us the degree of kinematic indeterminacy if the members are extensible. But here, as I have considered the members as inextensible, I will have to deduct the number of rigid members from it, and dk is equal to 13. So this is how you can get dk in case of hybrid structures. Thanks.